March 1942, Milne Bay, New Guinea. The tropical air was thick and heavy, smelling of decay and aviation fuel. Beneath the oppressive jungle canopy, the steel runway shimmered with heat. A twin-engine North American B-25B Mitchell bomber, designated 100, sat ready. The morning light caught the sweat on the brow of its pilot, Lieutenant John Gentry. This was not a bombing run. This was a rehearsal for suicide. They pushed the throttles forward. The engines screamed, biting into the humid air. The B-25 lifted, banking sharply toward the glassy expanse of the Solomon Sea. Their target, a discarded oil drum anchored 3 miles offshore. Gentry descended fast, pushing the control column until the wheels skimmed the wave tops. At just 20 feet of altitude, the ocean's spray dusted the canopy glass. The bombardier sighted the drum. The moment arrived. Gentry held the speed, steady at 250 miles per hour, refusing to climb even as the water rushed beneath them. The bomb bay doors opened. A single 500-pound general-purpose bomb dropped, releasing just 60 yards from the target. It hit the water, did not penetrate, but instead skipped like a flat stone across the surface, hitting the oil drum broadside in a cloud of shrapnel and spray. This maneuver was reckless. It was unauthorized. It was the invention of desperation, born from the humiliating truth that conventional tactics had failed entirely to halt the relentless advance of the Imperial Japanese Navy. Now, institutional caution had to confront the lethal physics of a ricocheting bomb. The first year of the Pacific War was defined by overwhelming defeat. The initial hammer blows of the Imperial Japanese Navy had scattered the Allied fleets and decimated their air power across the Southwest Pacific Area, SWPA. From Pearl Harbor to the fall of the Philippines, the pattern was clear. The Japanese secured their perimeter by moving vast quantities of troops and materiel by sea, almost unimpeded. Their supply lines were the arteries of their empire. The Allied response was crippled by distance and doctrine. The US Army Air Corps, USAAC doctrine, developed in the 1930s, prioritized precision, high-altitude bombing against fixed targets. It was a philosophy of strategic surgical strikes, not ship-to-ship combat. Heavy bombers like the Boeing B-17 Flying Fortress were majestic at 25,000 feet, safe from most anti-aircraft fire, but they were almost useless against fast-moving, zigzagging ships below. The results were demoralizing. Bombing runs were often conducted from such heights that the ships appeared as tiny maneuvering specks. The accuracy was abysmal. Missions involving dozens of heavy bombers would expend hundreds of bombs for a single near miss. Japanese ships simply shrugged off the sporadic damage. This failure was not due to a lack of courage, but a flaw in theory. The concept of the mast-level attack, a shallow glide down the mast of a ship to drop a bomb, was known, but it was incredibly dangerous and required a terrifying descent directly into concentrated light flak. In early 1942, the critical theatre was the defence of Australia and New Guinea. The Japanese drive toward Port Moresby was stalled, but their sea-based logistics were constant. The Allies were fighting a war of attrition, losing men, supplies, and morale to an enemy they could not starve. A radical solution was needed to break the naval grip, one that defied established rules. The skies over New Guinea demanded a new kind of aerial predator, one willing to fly lower than the seagulls. The genesis of this desperate new method lay with the 5th Air Force in the SWPA, commanded by Lieutenant General George C. Kenney. Kenney was a pragmatist, immediately recognizing the uselessness of established high-altitude bombing. His focus became clear: find a way to destroy ships, fast. The man who truly pioneered the solution was an aviation innovator and fixer named Major Paul I. Gunn, known simply as Pappy Gunn. Gunn, a civilian contractor turned officer, was obsessed with two things: making the B-25 Mitchell a tougher aircraft and making its bombs hit the target. He and his pilots began testing the near-impossible theory of skip bombing. The physics was simple, yet frightening. By dropping a standard 500-pound general-purpose bomb from an extremely low altitude, 10 to 50 feet, and at high speed, the bomb would not plunge into the water. Instead, its trajectory would flatten, and the bomb's streamlined nose would cause it to ricochet across the surface, striking the ship's thinly armoured side or hull like a high-velocity projectile. This required precise timing and mechanical adaptation. A regular bomb fuse was set to detonate on impact. If a skip bomb hit the water, it would detonate prematurely, wasting the weapon. Gunn's ground crews had to rig up a complex system using a 4 to 5 second delay fuse and a tail plate. This delay allowed the bomb to skip across the water, penetrate the hull, and explode inside the ship, maximizing damage below the waterline. The forces involved were immediate and major. The Japanese had built their ships to repel torpedoes, which attacked below the waterline, and high-level bombs, which struck the deck. They had not anticipated a weapon that approached horizontally, 10 feet above the waves, with the velocity of a heavy shell. However, the risk to the crew was astronomical. Flying straight and level at mast height, directly into a vessel's concentrated array of 25mm and 40mm anti-aircraft guns was an invitation to disaster. The USAAF brass, steeped in the high-altitude doctrine, viewed the tactic as suicidal, and officially it remained banned by high command. But in the unforgiving theatre of the SWPA, where necessity overruled doctrine, the pilots continued to train. They understood that the war would be won, not by safety, but by calculated, lethal ingenuity. The training runs became harder, the altitudes lower, and the results, against anchored hulks, became deadly accurate. The pilots of the 5th Air Force were forging a new, terrifying weapon system, one which now needed the perfect target to prove its revolutionary, rule-breaking effectiveness. To the pilot, the skip bombing run was a sensory overload unlike any other combat mission. It was a terrifying fusion of precision flying and sheer nerve. Standard bombing runs offered the comfort of altitude and distance. Skip bombing offered only the roar of the wind, the vibrations of the engines at full throttle, and the realization that the pilot was flying a multi-ton bomber like a fighter at 20 feet above a hostile ocean. The margin for error was non-existent. If the pilot banked too steeply, the wingtip would strike the water, causing an instant cartwheel and disintegration. If they pulled up even slightly too soon, the momentum would be lost and the bomb drop would be inaccurate. The target run was a mandatory, unvarying, high-speed approach that put the aircraft directly into the enemy's most lethal field of fire, the belt of anti-aircraft guns mounted along the ship's sides and superstructure. The crews called it threading the needle. The noise inside the cockpit was deafening, a mix of engine strain and the rhythmic rattle of their own .50 caliber machine guns strafing the ship's deck, a critical maneuver to suppress the Japanese gunners just before the bomb was released. This required a level of concentration few combat scenarios demanding every ounce of focus from the crew to hold the bomber steady, achieve the precise drop height, and survive the subsequent sharp evasive maneuver. The inherent danger of the flight was matched by the technical difficulty of the bomb itself. A standard naval anti-shipping weapon was the torpedo, which required a complicated, heavy aircraft and often failed. The skip bomb was simply a modified 500-pound or 1,000-pound general-purpose bomb, a relatively cheap and plentiful munition. The trick was in the fuse delay. If the delay was too short, the bomb would detonate upon striking the water's surface, harmlessly creating a geyser. If the delay was too long, the bomb would skip past the ship before exploding. Pappy Gunn's crews became experts at jury-rigging the standard fuses, often using 5-second delays to ensure the bomb would ricochet 2 or 3 times across the water, penetrate the thin steel plating of the ship's hull below the main deck, and then detonate internally. The low angle of impact, combined with the high velocity, maximized the chance of penetration before the ship's internal plating, or water resistance, could prematurely stop the weapon. This improvised engineering meant that the B-25 was now carrying a weapon that behaved like a high-velocity shell. It was a crude, brilliant adaptation of existing technology to solve a desperate problem. The Imperial Japanese Navy, IJN, was supremely confident in its defensive capabilities against aerial attack, but this confidence was narrowly focused. Their doctrine dictated a robust defense against high-altitude level bombers and dive bombers. Their deck plating was thick to repel vertical hits, and their heavy-caliber anti-aircraft guns were optimized for high-angle engagement. Japanese gunners were trained to look up. They were positioned and drilled to respond to vertical threats, not a horizontal, deck-level onslaught. When the first low-level attacks began, the shock to the Japanese crews was paralyzing. A B-25 flying 20 feet above the water was suddenly a blur, appearing from the smoke and spray just seconds before the impact. Furthermore, the B-25s were not just dropping bombs. Major Gunn had aggressively equipped them with banks of up to 8 fixed, forward-firing 50 caliber machine guns in the nose. This turned the bomber into a massive, flying strafing platform. The simultaneous combination of heavy strafing and the near-instantaneous skip bomb drop shattered the defensive organization of the Japanese crews, forcing them to duck for cover instead of manning their flak guns. The Japanese had not prepared for an attack that was both a heavy machine gun ambush and a high-speed horizontal bombing run. The most profound resistance to skip bombing was not engineering, but institutional. US AAF doctrine, codified by the war's start, explicitly discouraged low-level attacks against heavily defended vessels. The reasoning was sound: high casualties and limited effectiveness. General Henry Hap Arnold, the commanding general of the US AAF, viewed the tactic as an unacceptable risk, bordering on recklessness. The policy in Washington, and even in some less threatened theaters, remained fixed: high altitude, precision. However, in the Southwest Pacific, General George C. Kenney operated with a pragmatic autonomy granted by distance and dire necessity. He saw the reports and observed the dismal results of conventional bombing. He understood that the only way to stop the Japanese logistical juggernaut was to achieve destruction, not near misses. Kenney gave the men on the front line, particularly Pappy Gunn and the pilots of the 3rd Bomb Group, tacit permission to ignore the existing regulations. This became a powerful dynamic of command defiance. The pilots knew they were risking more than their lives. They were risking court-martial if the tactic failed disastrously and casualties were too high. The success of skip bombing relied entirely on this unique, almost rebellious relationship between a desperate theater commander and his fiercely innovative subordinates. They were betting their careers and their lives on the physics of a ricochet. The B-25 Mitchell was the perfect platform for this suicidal tactic. It was rugged, maneuverable for a medium bomber, and possessed a high top speed at low altitude. But its greatest advantage was the ability to carry a devastating arsenal of forward-firing machine guns. Early in the war, Major Gunn realized the critical need to suppress the ship's anti-aircraft fire before the bomb drop. His ground crews began mounting additional 50 caliber machine guns in the nose, sometimes stacking them in blister packs, or removing the glass bombardier's nose for a solid metal one bristling with heavy weaponry. The definitive configuration of the B-25 G and H models would later emerge directly from this field modification, featuring a formidable 75mm cannon and multiple forward-firing machine guns. For the low-level run, the bomber became a flying tank. The strafing was not meant to sink the ship, but to clear the decks of gunners. The combined effect of dozens of machine gun rounds raking the superstructure and deck, followed immediately by the bomb drop, provided a crucial 4 to 5 second window of suppression. This technological adaptation, transforming a bomber into a high-speed attack gunship, was what ultimately turned the forbidden, suicidal tactic into a highly lethal, decisive operational weapon system. The stage was now set for the first great test, where theory and defiance would collide with the full strength of the enemy convoy. March 2, 1943. The Bismarck Sea, north of New Guinea. The ultimate test of the forbidden tactic arrived not as a single ship, but as a massive logistical artery. The Japanese 8th Army was attempting to reinforce its defensive position at Lae and Salamaua in eastern New Guinea. To achieve this, a heavily guarded convoy was sailing south, 8 troop transports carrying 6,900 troops, protected by 8 destroyers of the Imperial Japanese Navy. This was designated Operation 81. General Kenney's intelligence had tracked the convoy. This was the chance to prove the low-level tactics' worth on a strategic scale. The plan was audacious, a coordinated assault using both high-altitude and low-altitude bombing. The B-17s would go first, forcing the ships into defensive maneuvers. Then, the B-25s, flying dangerously low, would sweep in for the kill. 8 o'clock hours, March 3rd. The skies were broken, offering cloud cover. The first strike wave of B-17s descended through gaps, dropping high explosive bombs. Their accuracy, predictably, was poor, but the effect was achieved. The Japanese ships began their evasive zigzagging. This made them slower, more predictable targets for the coming attack. The anti-aircraft fire, though fierce, was still aimed mostly upward. The second wave, the low-level strike force, consisted primarily of B-25s and Australian RAAF Beaufighters. The B-25 crews, including elements of the 3rd Attack Group and the 38th Bomb Group, prepared for their deadly approach. They had stripped their aircraft of every unnecessary ounce of weight and pushed their engines to the limit. The pilots knew that once they dropped below 500 feet, they were committing to a point of no return, where survival depended entirely on speed, nerve, and the effectiveness of their strafing guns. The tension in the cockpits was palpable. They were about to fly into the mouth of a steel trap. The distance from the target was closing rapidly. 11 o'clock hours, March 3rd. The B-25s descended from the cover of the clouds. The formation, led by pilots like Major Ralph G. Chelly and Captain John P. Walseth, split into 3 waves, approaching the convoy from different angles, a saturation attack designed to overwhelm the Japanese gunners. The altitude dropped, first to 100 feet, then 50, and finally settling into the deadly 20-foot zone. The Mitchells arrived not as bombers, but as flying walls of incoming fire. The fixed machine guns hammered the decks of the transports and destroyers. They ripped through the unarmored superstructures, silencing gunners, decapitating bridge crews, and shattering radio antennae. The B-25s were so low that the pilots could see the stunned, terrified faces of the Japanese sailors scrambling for cover. One B-25, piloted by Captain Walter Krell, targeted the destroyer IJN Shirayuki, the flagship of Destroyer Division 11. Krell held his aircraft steady, absorbing a continuous barrage of light flak that tore holes in his wings and fuselage. He pressed his attack, maintaining an airspeed of 240 miles per hour, aiming directly for the destroyer's midsection. At the critical moment, just 50 yards from the target, the bombardier released the single 500-pound bomb. It struck the water, made a perfect sharp skip, and slammed into the port side of the Shirayuki's hull, penetrating below the waterline. The 5-second delayed fuse did its job. A fraction of a second later, the bomb exploded internally, creating a tremendous plume of black smoke and forcing the steel plates outward. Simultaneously, other B-25s unleashed their skip bombs against the troop transports. The transport Kyokusei Maru was hit repeatedly and burst into flame. Another, the Teiyo Maru, received multiple hits to its engine room, erupting in fire and steam. The entire attack wave lasted only 4 minutes, but the damage was catastrophic. The combination of intense sustained strafing and the devastating internal explosions from the skip bombs paralyzed the convoy. The Japanese defenses, trained for altitude, were incapable of meeting this threat. Ships were already burning and listing. In a desperate move to save the remaining vessels, Japanese destroyers tried to lay smoke screens, but the low-flying B-25s simply followed the silhouettes of the masts through the haze. The myth of high-altitude precision bombing as the sole path to victory against shipping was utterly shattered in the churning waters of the Bismarck Sea. The Battle of the Bismarck Sea, fought over 3 days in the churning, oil-slicked waters off New Guinea, was an unprecedented victory for Allied air power. The numbers were staggering, representing a near-total annihilation of the Japanese logistical effort. 4 destroyers and all 8 troop transports were sunk. Approximately 3,664 Japanese soldiers, over half the embarking force, and hundreds of sailors were lost. The air attack was so effective that the subsequent loss of life was primarily due to drowning and strafing of survivors in the water by Allied aircraft seeking to prevent salvage and rescue efforts, an action that remains controversial but was deemed militarily necessary by some commanders to ensure the enemy could not reach their objective. In stark contrast, Allied losses were minimal. 5 aircraft were shot down, resulting in the loss of 13 airmen. The effectiveness of the low-level, high-speed attack against a major, heavily defended convoy was undeniable. The Bismarck Sea proved that the B-25, utilizing the skip bombing tactic, had become the most lethal anti-shipping weapon in the Southwest Pacific. Japanese operational reports from the survivors conveyed utter shock. Lieutenant Colonel Kazukane Omi, a staff officer aboard the Kuroshio, reported, "The attacks were made from only 10 to 20 meters above the surface of the sea, one plane following another in quick succession. We were so busy ducking and watching planes that we never got a chance to fire our anti-aircraft guns. The explosions were terrific, penetrating the thin plates of the hull. It was impossible to fight back." The psychological impact on the Japanese was devastating. Their supply routes, previously considered inviolable, were now exposed. The loss of a major reinforcement shipment sealed the fate of the Japanese garrison at Leh and significantly curtailed the ability of the Imperial Japanese Army to conduct major offensive operations in the South Pacific. The battle was a strategic turning point, signaling the final shift in operational air superiority to the Allies in the SWPA. The commanders in Washington could no longer ignore the success of the tactic they had previously dismissed as suicidal. The overwhelming success at the Bismarck Sea forced a dramatic and immediate change in Allied air doctrine across the Pacific. The suicidal, low-altitude tactic was no longer banned. It was codified and aggressively taught. General Kenney ensured that the techniques pioneered by Pappy Gunn and the 5th Air Force were disseminated to other commands. The air crews of the US AAF had proven that the most effective way to engage a modern naval vessel was not from safe altitude, but from a terrifying deck-level approach. This success necessitated further technological development. The experimental modifications to the B-25, such as the solid nose bristling with forward-firing machine guns and the massive 75mm M4 cannon added to the B-25H model, moved from field improvisation to standard factory production. The B-25 Mitchell was now permanently transformed from a medium-altitude level bomber into a dedicated ship killer and ground attack aircraft. Other aircraft, notably the Lockheed P-38 Lightning fighter, were also adapted with racks to carry fragmentation bombs for low-level suppression attacks, providing fighter cover during the approach. Strategically, the impact was profound. The Imperial Japanese Navy's previous logistical methods became obsolete. They could no longer move large forces openly by sea through contested areas. The victory at Bismarck Sea effectively strangled the Japanese effort to reinforce New Guinea, condemning their troops to a brutal war of attrition far from major supply bases. The Allied ability to sever these sea lanes meant that the entire strategy of island hopping became viable. Instead of fighting for every piece of ground, the Allies could now use their air power to isolate and starve enemy garrisons, leaving them to wither on the vine. The ability to destroy transports from the air fundamentally altered the balance of naval power in the Southwest Pacific, making the air forces the definitive factor in local naval engagements. The courage of those pilots who defied orders to fly at wave-top level had secured the path for the Allied counteroffensive. The Battle of the Bismarck Sea stands as a testament to the fact that victory in modern warfare often requires a complete rupture with established doctrine. The men who flew the B-25s at wave-top altitude were not merely pilots. They were the embodiment of necessary audacity. They took a tactic deemed suicidal by cautious commanders, and, through rigorous training and ingenious field modification, transformed it into the decisive weapon of the campaign. The legacy of the skip-bombing crews reveals a profound truth about the nature of combat. Necessity is the true mother of military innovation. When conventional methods fail against an intractable problem in this case, the relentless movement of Japanese naval logistics, the solution is often found in the places the rule-makers refuse to look. The pilots of the 5th Air Force succeeded because they were willing to trade the safety of altitude for the lethality of proximity. The event fundamentally changed the way the Pacific War was fought, confirming that air power could effectively substitute for surface naval power in certain theaters. It demonstrates the critical role of junior and mid-level leaders like Major Gunn and General Kenney, who possessed the vision and courage to defy rigid command structures for the sake of survival and success. The B-25, the humble medium bomber, became a legend, a symbol of the lethal, low-slung fury that broke the back of the Japanese supply effort. The cost was high, measured in the nerve and the lives of the crews who endured the terrifying, smoke-filled runs just feet above the waves. But their sacrifice proved that sometimes the only way to defeat a strong enemy is to take the most terrifying risk imaginable, flying directly into the face of fire to deliver the fatal ricocheting blow. The sea skimmers forced the entire Japanese war machine to look down, straight into the muzzle of its destruction.